Hello learners. So far, we have learned about joint probability distributions and we have also learned how to marginalize a joint probability distribution. In this lecture, we will learn about conditioning on random variables. If you recall, we have already learned about conditional probabilities of regular variables. Now, we will be expanding that knowledge and applying it to random variables. So, if we expand the definition of conditional probability to suit random variables, if x and y are two discrete random variables with joint probability function p of xy and marginal probability functions p of x and p of y, then the conditional probability p of x given y is equals to the joint probability of x and y divided by the marginal probability of y. Similarly, the conditional probability of y given x is equals to the joint probability of x and y divided by the marginal probability of x. Note that we can see a new subscript in our notation for the probability function. We have previously come across p sub y, which represents the probability distribution of y, p sub x, which represents the probability distribution of x, and p sub x y, which represents the joint probability distribution of x and y. Now, p sub x given y represents the conditional probability of x given y, or the probability of x conditioned on y. Similarly, p sub y given x represents the conditional probability distribution of y given x, or the conditional probability distribution of y conditioned on x. This is exactly the same thing we learned for the case of regular variables in our probability lectures, and now we have expanded that definition for random variables. Let's now look at an example of conditioning on random variables. So here we have the same joint probability distribution as the previous lecture, being the joint probability distribution of weather and temperature. We can see that the joint probability distribution table is filled out with all the appropriate values. And the question is asking us, what is the probability that it will rain given it is cold? So let's find that out. We are being asked, what will be the conditional probability of the weather being rainy given that the temperature is cold? So, from the definition of conditional probability that we just saw, we know that this is defined as the probability of it being rainy and cold divided by the probability of the temperature being cold. So, we need the joint probability of the weather being rainy and the temperature being cold, which is rainy and cold is 2 over 15. So, we have 2 over 15 divided by the marginal probability of the temperature being cold. So, the marginal probability of the temperature being cold is 1/3. Which is equals to 2 over 15 times 3 over 1. That gives us 2 over 5. And that is the conditional probability of it raining given that the temperature is cold. So, to recap, in the last few lectures, we learned about joint probability and marginalization. We learned about the test for independence for random variables. And we also learned about conditioning on random variables.